Hello, the topic of today's lesson is fractions. We're going to begin our fractions operations, such as addition, subtraction, followed by multiplication, division. But first, we need to look back, or review what we've learned in the previous year, since you guys probably haven't encountered fractions so far this school year. Let's compare which is greater, 2 out of 5 equal parts or 3 out of 8 equal parts. Well, as you can see, they're giving you a visual model. They're giving you the circles like the pizza pies, and they give you the bar modeling. And it's, in a way, it's difficult to say which one is bigger. Not that difficult, but we can see that 2/5 is greater just because it's kind of like this. So we can say 2/5 is greater. But before I go into comparing visually using bar models or even in a number line, look where 2/5 belongs in a number line. We split one whole, 0 to 1, into 5 equal parts or into 8 equal parts. And of course, 1 out of 5, 2 out of 5 is a little bit larger than 1/8, 2/8, and 3/8. But the most sure shot to compare fractions, I'm now on page 60, is not visually, not using a bar model, and not even the number line. The best method to compare fractions we learned in 4th grade is to first understand their denominators. And if they're different, we must find the common denominator, or what I call common language. Right now, these fractions do not understand each other, right? Language or common denominator. 1 is out of 5 equal parts, so the pieces are one size. 1 is out of 8 equal parts, so pieces are a little bit smaller. So how do we know? Sometimes the numbers are much more difficult. So let's first find least common multiple, LCM. We learned about LCM in the beginning of the year, about a month ago, in chapter 1, for 5 and 8. And you should know that both of these numbers are part of multiplication tables, resulting in the product of 40. 5 goes into 40 8 times, and 8 goes into 45 times. Therefore, it is 40 that is the common multiple for both of these numbers. And in order to convert them to an equivalent, we must multiply this fraction 8 times and multiply 3/8 5 times. And of course, results in 16 out of 40 versus 15 out of 40. And now it's super easy to compare. 15 out of 40 is, of course, smaller than 16 out of 40 equal parts. What we call these out of 40, we call them lookalikes or like fractions versus unlike fractions. 2/5 and 3/8, when they have different denominators, we call them unlike fractions. Not lookalikes, just opposite. Let's take a look at number 1. Again, we compare fractions and look at them. Of course, you can use logic. We have 2/3 and 3/5. We have 3/5 and 3/7. We have 4/5 and 5/6. We can use logic comparing fractions, but I want to practice the common denominator method. So let's first convert all these fractions into lookalikes, into fractions with the same denominator. Let's say 3, let's first find LCM of 3 and 5. That's 15. Both have common multiple of 15. LCM of 5 and 7 is 35. Let's write it down. LCM of 5 and 7 equals 35. In both cases, we just multiply the fractions, the numbers by each other. And of course, finally, for example, C, LCM of 5 and 6 is 30. Again, what did we do? We multiplied the two numbers by each other. It's not always that we will do this, but in this case, some of them are prime, so we just simply multiplied. Now let's find equivalents. 2/3 and 3/5. We must convert them to 15ths. In order to do that, 2/3 has to multiply by 5. What we do to the top, we do to the bottom. And 3/5 has to be multiplied times 3 times. So what we do to the bottom, we must do to the top. 2 times 5 is 10, 3 times 5, 15, 3 times 3 is 9. Now we know that 10/15 is greater, okay? then 9/15. Next example, 3/5 or 3/7. We know that both of them can be converted to equivalent fractions out of 35 equal parts, except 3/5 has to be multiplied 7 times, and 3/7 has to be multiplied 5 times. Let's go. 3 times 7 is 21 out of 35. 3 times 5 is 15 out of 35. We could have done it using logic. Of course, 21/35 or 3/5 is greater than 3/7. And we knew that because sevenths are smaller pieces than fifths, right? When we split something into 7 equal parts, we get much smaller parts when we split something into 5 equal parts. And finally, example C, we have 4/5 and 5/6. We identified that the common denominator, also called common multiple, should be 30. What do we do to 4/5 to convert it to equivalent out of 30? Well, we must multiply numerator and denominator 6 times. 4 times 6 is 24 out of 30. That's the equivalent. And 5 out of 6 has to be multiplied 5 times. 5 times 5 is 25 out of 30. Now it's easy to compare. 25 out of 30 is greater. Therefore, 5 out of 6 is greater. I hope this page 60, you really find it helpful. This method of finding lookalike fractions, bringing, or what we say in mathematics, bring both fractions to the same denominator. Bring both fractions to the same denominator by finding equivalence. Bring both fractions to the same denominator by finding equivalence. Page 61. Super easy problem. There are 12 flowers. Yeah, I see that. 8 of them are roses. Not bad. 8 of them, see? 8 out of 12 are roses. Okay. Now, so we can write it down. This is 8 out of 12, and this is 4 out of 12 are maybe daisies, right? But we can also look at them as 3 groups. This is called grouping, right? We can grouping. We can group the flowers into 3 equal groups. And we have 1 out of 3, 1 out of equal 3 groups, and 1 out of 3, which means that the red flowers are 2/3. 2/3 of the flowers are red or roses. But take a look at the mathematics. 8 to 2 and 12 to 3. We found an equivalent fraction. How did we do that? We divided by 4. 8 divided by 4 is 2. We reduced the fraction. That's called reducing. Reduced fraction to simplest form. I hope you guys remember from last year, simplest terms or simplest form. Now, what did we do to the denominators? 12 to 3. Of course, we also reduced it 4 times. What you do to the top, you must do to the bottom. What you do to the bottom, you must do to the top in order to remain equivalent. Equivalent. Now, what does the number and letter represent? Well, where are those numbers and letters? Those letters are A and B. All right. What does letter A represent? I see we have 1 hole, and we have 2 holes, and we have 3 holes. From 0, we have to 1, and from 2, we have to 3. That's a number line. Now, how many equal parts? Let's count. 1, 2, 3, 4, 5. These are 5 equal parts. Oh, of course, I didn't have to think like that. We have fifths, 5 equal parts, right? What happens after that? Well, we keep counting by fifth. 1 and 1/5. 1 and, let's write it down. 1 and 2/5. 1 and 3/5. Therefore, number A is 1 and 4/5, or equivalent to 9/5, right? Let's say 10 out of 11, 10 out of 5, 11 out of 5, 12 out of 5, 13 out of 5. Oh, what happens here? Must be 14 out of 5 equal parts, which is some number between 2 and 3. So it's 2 wholes and then 1, 2, 3, 4 fifths. 2 and 4 fifths. 2 and 4 fifths, 1 and 4 fifths. Okay? These are called mixed numbers. Mixed numbers are made up of a whole and a small fraction, okay? And we write it very neatly. Mixed numbers are called 2, that's the number of wholes, and then somewhere in between we put the fraction bar and we say 4 out of 5 equal parts, okay? So these are called mixed numbers. Mixed numbers. We learned about them last year. And the numbers on top, right, where the denominator is larger, are called improper fractions. Improper. They're so improper, right? They're so improper where the numerator is equal or greater than the denominator. We have a much larger numerator and a smaller or equal denominator. Okay, let's keep going. Now we have to do some conversions. We're giving improper number and we have to convert it to a mixed number. Or the other way around. So 11 out of 4. Let me do this together. We can split 11 out of 4. Well, there are multiple ways to do that. I would say, how many times 4 goes into 11? Well, we know that 8 out of 4, right? That would be 2 wholes, and the remainder is 3/4, right? 3 out of 4. So we can say, see, we can split 11 out of 4 into 2 parts, right? 8 out of 4 is just 2 wholes, and the remainder is 3/4. So we just went from improper fraction into a mixed number. We said improper, we translated to mixed number. Now we are going to take care of the opposite trip. We're also going to work from mixed number. We're going to convert it back to improper fraction. Take a look at number. Take a look at number 15. Number 5. We have to address from express each number and translate it into improper fraction. So let's say A and B. 1 and 4 fifths. Well, 1 is the same as 5 fifths plus 4 fifths. Of course, gives us 9 fifths, and 9 fifths is very improper. Yeah, bigger numerator. 2 and 2/3. Well, we know 2. How many thirds are in 2? 3/3 are in 1. 6/3 are in 2 wholes. And another 2/3 equals 8/3 altogether. Yes, very nice. Now I'm going to show you a different method. Because 2 and 1/4, well, we know how many quarters are in 2. How many quarters are in 2? We know there will be 8 quarters plus 1/4. Altogether will give us 9 quarters. And finally, example D for doggy. How many 6s are inside 2? Well, we know 6 times 2, there should be 12 6s. That's equivalent to 2 plus another 5 6s gives you 17 out of 6. And all 4 of these fractions are very improper, totally improper, because they have a much larger numerator than denominator. Okay, let me move forward. Now we have to translate in a different way. See, we did from improper to mixed, then we did from mixed to improper. Now let's say, what do we need to do here? Express each of the following as a whole number, a fraction, or a mixed number. What's very important are these 2 last words, simplest form. Let's practice. Let's go side to side. 8 out of 12. let's reduce this. We have to find common factors. Both 8 and 12 are divisible by 4. What we do to the bottom, we must do to the top. So 2/3 is an equivalent. What about 9 out of 12? How can we reduce? How can we simplify this fraction? Well, we know both 9 and 12 are divisible by 3, right? That's their common factor. 9 divided by 3 is 3. 12 divided by 3 is 4. We found an equivalent. 6 out of 9, we divide by 3. Also results in 2/3. 2/3, we divided by 3. 6 out of 12, well, that's just 1/2. We know 6 is a half of 12, right? 13 out of 5, well, this is improper fraction. We saw them above, right? When we have a much larger numerator and a smaller denominator, improper fraction. Let's kind of highlight them here. Let's highlight improper, 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 improper. Let's convert them to proper fractions in the most reduced state. 13 out of 5, or 13/5. Well, how many times 5 goes into 13? It goes 2 times, right? 13 divided by 5 is 2 times. And then there will be small piece, 3/5 will be remaining. 21 out of 3, or 21/3. Well, how many times 3 goes into 21? 7 times. That's the most simplified form, just 7. Just 7. Finally, last two examples. 24 out of 9. Well, how many times 9 goes into 24? 9 goes into 24 2 times. 2 times 9 is 18. What's the remainder? Remainder is 6 9s. And everything would be good, except we can further simplify this fraction. We must make them simple, make them beautiful. 6 out of 9 is equivalent to 2/3. And if you wonder how I did that, well, I just divided both the numerator, the top, and the denominator by the common factor divided by 3. Okay? Now, finally, 56, or 50 out of 6. 6 goes into 50 8 times. 6 times 8 is 48. 48. 50 divided by 6, where 6 goes into 58 times. So what would be the remainder? Oh, 2 out of 6, except again, 2 out of 6 is not simplified. It reduces to 1/3. And if you wonder how, we found the common factor. We divided by 2 on the numerator and divided by 2 in the denominator. What we did to the top, we must do to the bottom. What we do to the bottom, we must do to the top in order to create the fraction in the simplest form. Finally, the last exercise on page 62, we need to compare the fractions. And many of you will use logic to do this. You will use logic to do this, and that's fantastic. I will try to convert. Notice we have improper fractions in example A. How do I know they're improper? Well, the numerator, both cases, is larger than denominator. So here we have 1 and 1/2, and on this side we have 1 and 1/4. Well, which one is larger? Which one is larger? Of course, 1/2 is larger than 1/4. So that's the sign we use. Now, example B, 2.5, or 2 and 1/7. We know half is larger than 1 out of 7, because half is such a big chunk. You only divide it into 2 equal parts. And to make it out of 7, you split it into 7 much smaller parts. Now in example C, it's actually much easier. 4 wholes is always bigger than 3 and some fraction. What do we have in D? We have a mixed number, 1 and 5/6, and we have a improper fraction. Let's convert it. 6 goes into 11 one time, and how much is still remaining? 5 out of 6 parts. Guess what? They are equivalent. equivalent, and we can just put equal. Finally, last two examples. E for Eddie. 4 wholes and 2/3 and 9 halves. Again, let's convert 9 halves. Well, how many times 2 goes into 9? 4 times. And 1 half, wrong writing, and 1 half is remaining. So we know 2/3 is bigger than 1 half. So this would be the correct symbol. And 3 or 15 quarters or 15/4. Well, let's convert. 4 goes into 15 3 times. 3 times, and the remainder is 3 times 4 is 12. The remaining is 3/4. Of course, 3 3/4 is larger than just 3. I hope you found this lesson useful. I went through every example just to look back and review grade 4.